Good afternoon. Yeah, so this hall is very familiar because many years ago, my first ever meetup in London happened here. It was a London Microservices meetup. So good memories from there on, plenty of meetups here, downstairs, etc. Just a word of warning, I know few of my colleagues here in the audience, and I usually, when I talk, I hype a lot about what we do at Lego Group. So if you see any of them shaking their head saying, Sheen, that's not true, just ignore them. I will deal with them later. Right. My name is Sheen Brisals, and I've been with the serverless technology and community for a few years. So I have the humble recognition of serverless hero, and I've been in the industry for many years with big and small companies, bunch of technologies and things like that. So currently I'm settled on serverless. So two common questions I always get asked. First thing is everything at the Lego Group serverless? The answer is no. Because as you can think of any big corporate, you have number of divisions. So the highlighted path is where I and most of us here belong. And that's the division of the Lego Group that takes care of predominantly Lego.com and all its surrounding services and things. They're all kind of mostly on serverless. That doesn't mean that other teams don't do serverless. There are serverless teams across the organization, and also legacy on-prem solutions still very active, as well as containers, clusters, and all sorts of things. So that's kind of the mix of what we do. The second question is, how much of Lego.com is serverless? Because I always talk about Lego.com, serverless, then I always get this question. Because people still think that you use serverless for some background, bad job. Of course, image processing, PDF transformation, blah, blah, blah. Those days gone. But we are mainstream now with serverless, okay? So this is Lego.com, and if you visit Lego.com, you pick products, put them in the basket, continue your journey, check out process, put your address, email, payments, etc., etc. Everything happens behind the scenes, handled by serverless microservices. So that means serverless being used for client-facing, customer-facing applications, high volume, big important applications here. So this is a very high-level architectural view of Lego.com. So the box is the back-end microservices. They're all 100% serverless. And in the front end, we have a bit of Fargate and the other typical browser technologies. Okay, now who can recognize this? Anyone? Okay, so this is old Channel 4 motoring program, back in those years. The reason it came to exist because of competition. It's a competition-driven program. The days when Top Gear used to be talk about, automobiles and not somebody else's garage and farmers and etc. So that's how it came to be. And typically, if you look at our software industry, we have plenty of driven things. In our gravity-driven world, we are all driven. Like, we are here because driven by event-driven architecture, right? So, the TDD, BDD, schema-driven, API-driven, all these kind of things, we are familiar with our software development process. They all kind of have the driven approach to get us do something. Now, model-driven, data-driven is key thing, and of course, domain-driven design. I will touch upon that later, and event-driven architecture. But has anyone heard of failure-driven development? So that's where our story starts. Welcome to my talk. So it's not a road. It's a runway, basically, because when we moved to serverless, we were basically running a race to get something out within a shorter, time span. So I'll go back in time to, to give you a context of, where we started, and we will look at what were the ambitions for us those days, where we wanted to get to. So that's how the serverless came into the picture. And I will focus more on how the event-driven architecture expansion and the acceleration happened along the journey, and I'll focus more on microservices and to give you a different, unconventional meaning of doing microservices, and then briefly touch upon the benefit it has brought us to the Lego group. So going back a few years, of course, always there is a villain, right? So this was the old Lego.com shop, the legacy system. As you can see, bunch of application servers, JBoss, if you're familiar with those sort of things. And the release process is a big occasion. It doesn't happen often. It only happens few weeks or once in few weeks or months. But when it happens, it needs to go through certain ceremonies, like you go through these things. But if any of these things failed, then you go back. So that going back means you spend another 2-3 hours working together with a couple of engineers to make a release. And imagine this was the pain. And I have a bug which I logged, I remember logging those days. It's a real stat. If you are familiar with value stream mapping, try to work out the waste and the goodness of this sort of 6 months period. So these were kind of the pains that the team and us were going through. At the same time, the popularity of Lego.com was going up. More visitors coming, new product launches, and all these things happen. So then eventually, one Black Friday, I prepared as we could, as much as we could, but even though our QA engineer at that time, Jason, was able to bring the whole thing down within few seconds with his clever scripts, we didn't have any solution. We still had to go because there was no other way. So as the traffic peaked, like if you are familiar with the Black Friday, it's on the dot 12 o'clock, you get the vertical spike, right? If you survey, you good. If you're flat out, okay? And at the same time, one by one, within few seconds, one by one, things went down. So the legacy tax system stressed out. That brought SAP down, and that put strain on the e-commerce platform. So that went down, and what do you get? Yeah? So I shared this picture millions of times to set the context. But today I'm sharing not because of where we started serverless, just to point out the failure points we had with this sort of setup those days. So if you look at the points, it's like on-prem, monolith, all the difficulties with the scaling and the limited number of thread pools or the database connections you have with the typical the SQL server, those setup, RDBMS, etc. And if you have your modern front end, that can hit very hard the back end, right? Number of API calls and all sorts of things. So all these were the kind of the failure points that kind of pressed us hard to find a better way of doing things. I mean, serverless wasn't in the picture at all. So we were kind of toying out different ideas, but serverless eventually came in for good. But these were the kind of the things that were up against. At the same time, from futuristic thinking point of view, from business side, they wanted to achieve more things. They wanted to reach out to many customers and many children around the world. They wanted to be innovative. That's one of the reasons why we don't use a package, Shopify or some other solutions, because we want the freedom to do things the way we want to do, innovate and add to bring benefits to the customers. And the other thing is like getting the minimum viable thing, and how can you make it more a maximum valuable thing? So kind of MVP to MVP. So another important point I heard a couple of talks touched upon is the observability, the visibility. Business needs to know what's happening across different parts of the ecosystem. It's not just one thing. There are many things happening. So these are the business side of the goals. Then technical needs, you are all must be familiar with all the the standard things we talk about: scalability, resiliency, observability, all sorts of things. And other thing is, I talk about the sustainable product. It's not the sustainability as we relate to the environment. This is a sustainable product that can last long. It has a longevity in terms of its lifetime. It's not like do it once and then dump it for maintenance. Those days gone. So we need to, kind of build sustainable products. How do we do that? Application needs to be modular. It needs to be extensible. These two go together, because if it's not modular, you can't extend it, right? And then, of course, it needs to be observable. So you need to have the right metrics and the logs and everything, so you know exactly what's going on in your system. So these requirements are kind of, came in. But how do we get to all these things? We had a number of challenges. Now, those days, serverless almost unheard of. No one wanted to try out. So combined with all these things, we were up against. So at some point, somewhere, someone made the decision to try out something new. But when I say try out something new, easy for me to say. But often, we see two types of technology adoption. One, I would say, is the speedy adopters. So these are the teams or the organization. They look up at the technology, they do a quick assessment, they start something new, simple, experiment, iterate, move on faster, get through. These are the teams and organizations, they race ahead when it comes to the competition or the technology, the curve. On the other side, we also have enterprises and organizations, what I call the endless experimentation teams. So these are all kind of more puristics. They are always judgmental, and they need to know everything perfect before they can do anything. If you convince them with everything, then some clever bloke at the corner will say, oh, what about vendor lock-in? Oh, then gone back to the same backstory again. So then they struggle again. So these are the teams, they kind of fall behind when it comes to the competition, because these days, every other day, the new service or a new feature comes out, right? So if you blink your eye, then you fall behind. That's how the technology world is evolving. So you need to be kind of pragmatic, and the gap widens. So that's why important to take a bit of risk and take the first step. So we took that step, and I like this picture for many reasons, not just for, when you start walking, you put your first step. It also will help with concepts I come in later, like how do you tackle a complex domain, okay? In order to tackle a complex domain, you need to make an entry point. You may need to make a first step to kind of get there and then slowly, move around. So I always say that when you start serverless, it's not going to be perfect. But try to become perfect as you iterate through, okay? Now, Alan Helton, he is a new serverless hero. He put it recently in his blog post nicely. He said, do it right, do it better. Simple. So that's kind of the mentality we need to have when we kind of, move into serverless. And, as you probably know, if you keep on thinking something, it's not going to happen unless you do it, okay? So anyway, first, event-driven computing. The first simplest possible architecture piece for event-driven is this one we came up with. It's a simple data flow kind of thing, and it was amazing because it was a new experience for everyone at that time. I'm talking about 2018, and everyone was surprised. But cool thing was, we were kind of doing the strangler pattern at a large scale as we were moving from legacy to the serverless. And we noticed that even with all the different services coming and making this solution, it was faster than the legacy. So these sort of the little visible improvements that gave more confidence to the stakeholders to try out more and more. So that's how we started building the event-driven computing and architecture from there on. So the first one is all about the event-driven expansion. Now that we got the grasp of things, let's try out something. And so the simplest thing I showed you expanded. So we quickly put together around 15 or 18 different pipelines. And as you can see, it followed two of the, the most common software engineering patterns we follow. Can you name them? What's the first one? Copy-paste, right? Second one, copy-paste, edit. Exactly what happened. But jokes apart, it taught us the granularity of serverless, the power, because we were able to tune these queues as we wanted. We were able to tune these Lambda functions as they needed to be, based on different parameters. And then from there on, clickstream event streaming. So now we are kind of, entering the big boys territory, like kind of, millions and millions of event streaming going through. Luckily, we have services. AWS provides Kinesis. So we were able to understand the power and how can be event-driven even with this volume of data coming in. You don't need to be scared. So this happened, and then many other things. So this taught us how can we deal with the batch, long-running batch jobs and do event-driven computing to notify people and to do a bunch of things. And customer data migration. So this kind of taught us something new. So say, for example, we were migrating to a new platform. We had tens of millions of customer data sitting in the old system. What do we do? Typically, we would employ somebody or a team to do the mass migration data from old to new. But someone asked the question, what if good proportion of the data nobody is going to use? Customers moved on, customers created new profiles, etc. Why do we need to kind of move all the deadwood? So that's when we took the decision to trust event-driven architecture. We said, okay, we're not going to do mass migration. We will do on-demand migration. When a customer comes to the new platform, we will do the event-driven magic behind the scenes. We will get the data, grab from different places, put in the right way. So this is how it's still working. So these are the situations where as architects or the team or stakeholders and leadership team, you need to make a, kind of a take risk, decision, move on. Okay, and many things happened. I'm not going to go through them, but you might be wondering, you haven't seen Event-Bridge at all in any of my diagrams so far. Yeah? Yeah, because it wasn't there. The reason is, we moved to serverless on this date, and Event-Bridge was released on the following date. Now, so that's good, because this was something we were missing when we were going through the initial migration, because now we have more wings. So that's when the event-driven architecture phase 2, the acceleration phase started with the blessing of Event-Bridge. Now, Dave Anderson is around somewhere. His new book is coming out. He once said, the event-driven architecture, serverless, the small iteration, perfect recipe for, success, massive success. So Dave kind of helped Liberty IT to move to serverless, and, so it was experience. So if you meet him, pick his brains. And I always say that the agile, iterative, event-driven way of doing serverless is like, as a takeoff. Because you need to do quite a bit of things initially to get to a stage, but once you lift it off, then you can keep on going because you get the momentum. You know exactly what's happening. This is what you experience in many organizations such as Lego Group or Liberty IT or Post-Terminal and so many other successful serverless adopting places. You see this thing. Okay, so now it's all about architecture. But thing is, as we all start serverless, we start small, right? So we start small, we experiment something initially, and then we start adding things. We draw these lines because we are under pressure to prove that this works. Because everything is new, people are looking at you, what you're doing, and you need to do something. And most importantly, you need to prove your colleagues because there are, hardliners, they don't want to because they are happy with their clusters and, containers. You need to convince them, oh, this is shiny and cool, come over. So that needs to be done. And the other thing is, you're not just, we're not paid for, playing around with Lambda, right? So we need to produce value for the business. So stakeholders will be keen looking at what these kind of new thing these guys are working on. Are they producing something? So all this pressure happens. So what you forget is the tangled mess of what you built. So you end up with the tangled architecture, or in ThoughtWorks terms, lambda pinball, because was here, all over the place, you come in circles. So I think Gregor talked about this sort of endless loop. So it's possibility. So what do? What's the solution? Of course, microservices, right? Yay, more royalty for Sam Newman, good. So it's good. I'm not, sorry, jokes apart, it's good. But thing is, how do you do microservices? Okay, so you bound the microservice boundary. Now you are kind of moving your resources and things all around. But thing is, you just carry it forward, all the tangled mess into a different way. So you still have the tangledness around. This is where Event-Bridge comes in. And this is exactly the reason why we took on to Event-Bridge as soon as it was released, because it clears up the mess, access the choreographer, deals with the publishers and subscribers and events and transport and all sorts of things. You find a bit of a harmony when you put Event-Bridge in place. So this is where the event-driven architecture acceleration kicks in. Now I talked about choreography. Let me just a couple of slides to clear out the choreography and orchestration. So choreography in a sense is like a sort of dance or whatever you call it, because the fact is, once the movements are all kind of choreographed, they just perform based on the music or the tune or whatever. You don't need to tell them this is how you need to do, etc. They just perform. Similarly, subscribers, when they get an event, they're subscribing application or services, they know what to do. If it's order placed, yeah, okay, I'll deal with the payments, okay, fine. And there isn't somebody kind of, instructing those kind of things. And, you heard a lot of things today. And then on the other side, we have the orchestration. But one thing with choreography is use it to coordinate between microservices. So that keeps them clean, separated, decoupled, all sorts of all loosely coupled. Now, on the other hand, orchestration. In orchestration, there is somebody, okay? There is a conductor, instructing different parts what to play. So this is like the step function area, where you have a workflow and you have long running and you can do a bunch of things. I'm not an orchestra person, to be honest, but often what happens is like when I listen for an orchestra, you follow the music and everything, then the conductor will come to this state. Everything goes very quiet and calm. People like me start clapping. But then with full flow rate, the whole drums and everything comes up. That's more like the step function's wait state. It just sits there quietly before something triggers to come up. Anyway, so what I would suggest is, if you're using orchestration, try to use within the microservices so that you don't cross the service boundary to connect with the different resources across different services. And then now with the power of task tokens, we can do distributed orchestrations. Next talk, Sarah doing downstairs, she's going to deep dive into the distributed orchestration and give you more idea and demonstrate how it works. Okay, now, when we put music and dance together, everyone likes, right? So, orchestration, choreography, that's where the magic of event-driven architecture comes alive, okay? Right, so, back to microservices. What I'm going to talk about is pieces. Not the typical microservices, all these 5 microservices like customers, checkout, payments, orders, and something else. That's all you see all the time. We need to go deeper. We need to go deeper into the traditional microservice. That's what I will be talking about today here. Now, who has read Domain-Driven Design? Okay, quite a few. It's not a book. It's an industry, okay? Because the number of books were written or is still being written to make people understand about domain-driven design. The number of online and in-person courses where people pay thousands of dollars to understand it, and then you have dedicated conferences and everything. So it's not a simple thing. It's a big industry behind. But thing is, it came 20 years ago. Now, how do you make the today's generation of engineers understand domain-driven design. And most of them, they don't know OO principles. DDD is full of UML diagrams. They have no clue what it means, UML. So we need a way of making it understood by the new generation of engineers, okay? And it has a bunch of good things, okay? Now, domain model, this is important. This kind of, we can kind of interpret and teach our engineers. And supple design, this is how, as I mentioned, making the design live longer. So these are the common principles we can adapt and take forward, irrespective of whether you read domain-driven design or do you go by with all the kind of, strategic design and various other things. So these are the good things. Bounded context, yes, of course, the boundaries and the, the anti-corruption facades and distillation is something associated with, the pieces I'll talk about, is kind of how do you distill, how do you kind of, refine, go down and, break the monolith into pieces and identify those things. So these are all good things. And I was watching a, YouTube video on Event-Drvien a while ago, I think a couple of months ago. And it had 5 or 10 minutes of, the DDD concepts and then 40 minutes of coding. Okay, I don't know who watches 40 minutes of Java coding nonstop. So I just fast forward. Then at the end, I was kind of going through a few comments because I had some thoughts. Who is going to watch this? And I found this comment by somebody. Exactly what I was thinking. Yeah. So go microservices and think of asynchronous and the event-driven architecture, and because that was the kind of, that's what we are now these days. I mean, there may be still kind of, typically people doing this sort of monolithic, the application development things, but this is how we enable business to, add more value with all the modern technologies and cloud that we have. Anyway, so back to the talk. So if you see the domain view or a subdomain view, for me, it's like looking at the forest. You need to have the view, okay? You need to visualize that. But if you're thinking of pieces, that is more of looking at the woods or the trees. So you see the difference. So you need to have the whole view, but when you start tackling a problem, you go deeper, you go forth. So I usually say that, visualize the whole and focus in parts. Now, I like this conversation between a man and woman in the movie Mamma Mia. So it's a life, problem they're discussing. The man would say that, oh, nothing is simple, everything is so complicated. So more optimistic woman, she would say that everything is simple if you break it down. This is exactly how we approach a domain when we kind of, think of event-driven architecture and breaking things down. To give another example, so this is a portion of our cosmos, okay? So we get great pictures these days with the new telescopes, but doesn't give anything. The thing is, if we zoom in, I know Greg talked about, zooming in earlier on keynote. If you zoom in one of the orange dots, you get to see the galaxy, okay? So go focus into the galaxy, you identify the stars and the planet, and the patterns. So you keep going. So you find a planet, and then you keep going. So you find the cloud formation, not that cloud formation, but So keep going until you find you and me somewhere. So that's kind of the way distillation or zooming in or going deeper needs to be. That's how it because serverless gives us the ability to go granular. It's one of its powerful things. Right. So what is a set piece that I've been talking about? So think of filmmaking. Okay, so they don't shoot the film from start to finish. Let's forget the linear and all those kind of things, the normal films that we watch. Same way, theater. It doesn't happen start to end. They have different scenes, they change the the backdrop and all sort of things. Football, this is where I borrowed the term, by the way. It's so common in English football to say that set piece play, right? So this team is good in set pieces. So what that means is they create opportunities to score goal. So people practice for years to bend it like Beckham, okay? So that's sort of the way. So that's again parts of the whole match. And of course, when you build a Lego model, you don't start with your first piece and the last piece, all right? You identify parts that you can build in isolation and bring together. So set piece development kind of, the methodology or the concept is like you do in pieces, but each piece you can plan, rehearse, test, etc. before you take to production. And then you can bring things together. How do you bring together? We'll see. So for example, say this is a payments domain or subdomain, as you wish. And if you think of as a typical, the sort of a traditional textbook style microservice, it'll be one service. The thing is, there'll be one pipeline, one delivery pipeline, and you will have something like this. But the thing is, what if a part of it changes all the time? Because if you work in the payments, you know that card providers, banks, etc., they keep changing the authorization window, etc., depending on currency, country, etc. If this changes all the time, why do you need to deploy everything else all the time? Can you not separate it out? So these are the thinking that we need to develop when we doing event-driven architecture and building microservices. You need to go kind of deeper and granular. So another way of looking at it is like, okay, so authorization, you can pull that out as a separate microservice. Then how about settlements or capture? This is when the funds actually transfer. This is more of a background task. It's nothing to do with your authorization part. You can easily take that part away, keep it separate, so that because this is more of a batch, you get dump of tens of thousands or hundreds of thousands payment IDs to clear. Okay, so it has a different scaling requirements and all sorts of things. So you can easily pull that away. Similarly, you can identify many parts and make them separate. Notice one thing though, are they all still within the boundary of the actual microservice? So that is your context and the boundary, all right? So I'm not going outside, I'm still staying inside. So this is one way of looking at it. I will go through an example soon. So the advantage is that you have independent delivery pipeline. Okay, so how do they work together? So if you take the examples I showed you, how do they kind of edit film or how do they put together a show? Because there is a dialogue, there is music, there is the conversation or background score. This happen. These kind of gel together, bring different scenes together, so you don't kind of feel that they are kind of disconnected. Same way when you build model, Lego model, for example, you have different kind of interface or connectors. They're not the same. So some are, attached, some kind of move around, some kind of, swing. So these are all the different flavors of interfaces. So how do we make it work when it comes to microservices? So we have APIs. So we have messages. We heard a lot in the keynote. So we have events. And then on top, you have these two wonderful ways of doing things like orchestration, choreography. So they kind of, make us do the big thing in a seamless and, cohesive way. Right, so APIs, messages, I talked about events, we heard a lot because it's event-driven architecture conference. Okay, so let's go through a case study. So this is about a loyalty service platform, which is currently in action at the Lego Group. This is simple terms. So this is about helping a customer coming to a store, as a Lego retail store, presenting their loyalty card, and how can the store help them to reward, earn points and redeem rewards and things like that. At the same time, someone new to loyalty can come and join the program as well. So the important thing is there is a public API. A loyalty service provides public APIs, can be used by a bunch of consumers, internal as well as external. And so that's a public API. So how do you start? So you probably start with a C4 model, a couple of models. If anyone using C4 model, okay. If you use C4 model for serverless beyond this one, let me know. Okay, that's where I struggle because up to this level I'm fine, but beyond that, how do you go for serverless? No idea. Anyway, so let's do some exercise. So this is a loyalty service platform, the big box. So as you assume, you've been through the domain, subdomain, and all the bounded contexts, etc., etc., etc. Ubiquitous language, and all these things happen. So you know roughly what you're building. Okay. Now, how do we start building? How do we start identifying the pieces? For example, Okay? So there is a public API, right? So it is hosting public API. Why don't we just take a core microservice that acts as the API landing zone? Okay, so all the requests come in there. And it may not do a bunch of things. It may do essential things to do, the essential things for those kind of endpoints we offer. So that comes in. The second thing is, think of third parties. These people often ignore. As much as possible, isolate the interaction with your third parties into a particular service or two. Don't dot these things around all over, because tomorrow you may change your third party. Okay, that means you don't need to change all over the place. You just isolate into certain services. So you identify the services, microservices that you want to interact with those third parties. So this is not, I'm not talking in general everywhere this is applicable, but these are the sort of the ideas you need to think when you break the domain down or start building event-driven architectures. Okay. Now this really helps. For example, we had an issue with our CRM system and none of the customers were affected. Only that service had to deal with all the backlog and replaying and all sorts of things. This is a common thing. And so that happens. So next thing, identify the sort of the common resources. If you have event buses, a common resource across, with these different microservices, and also sometimes you have, sort of a static resources, as we call in serverless, like, certain S3 buckets or certain other things. So you can group them into a single service. And identify non-business logic activities like administration, client admin, OAuth, and these kind of things. You can easily wrap a separate microservice to deal with. So that means they don't need to kind of mess around with the other services. The other thing is you need to keep going. Like you have async business functions. Say for example, someone is submitting an order. So you do the initial validation. So the sale loyalty core does the initial validation. Then it needs to go through many things. So the many things, you don't want to keep your client waiting when you do all those things. So you can easily decouple that, and you have a different mechanism deal with failures and things like that. So that is something like that you can easily be taken out. So that comes in, and you think of event source. So when I say event source, I need to make something clear here. When we say event source, it's not just about replaying the events to build your state. You can have a different interpretation for event source as well. In this case, it is used as a store to record of all the interactions with all the clients, so that if anyone raises a request, you know exactly what happened. Not necessarily for replaying and rebuilding the whole thing. So that's how it happens. So these things, it can be kind of taken care by a different service. And fraud detection. So if you're looking at payments or these sort of things, you should have some mechanism to identify, okay, this looks suspicious. What's going on here? Because this customer is kind of redeeming again and again and again, or some sort of pattern you need to have to identify these things. So these can be isolated. They don't need to be kind of sit together along with your core business things. They kind of step back and stay behind the scene and go through. And think of management tasks. So I briefly showed you the voucher generation. Similarly, if you have any batch jobs, they don't again interact with the mainstream operation of your functionality. Take them out, and you can keep going. And notification webhooks and other things. So isolate them, because I'll show you why. New features, if they don't need to mess around with the existing thing, keep them away, keep them separate. So this is an example of how you can keep going, identifying these pieces. I know it's a bit unconventional, but within your, if you're familiar with the DDD, with all the aggregates and all sorts of things, you can kind of relate. But keep going. So what could be the next one? Anything could be next one. So handling a lot. So here is an example of how these things to work together. So for example, an order comes through, and it's there's a session data store, and it's kept there. And this is part of the loyalty core. I mean, I'm just showing a simplistic view, say, to give an understanding, okay? Now, that sits there. It does its validation, given back the response. But what it does is, it does a bunch of things. It sends few events onto the bus because it's, for event source purpose, it needs recording every request response. So those events carry the data, and it goes and stores there. And at the same time, another event like order received, or the actual event names could be different, but anyway, so that goes, and that will then kick off something else, order processing. So it now knows there is a new order. So but with a bunch of details, it can do all the discount proportioning and all sorts of things. There will be other events depending on the success, failure, etc., etc. And the order processing is a complex thing because it has a state machine, something like this. So definitely you don't want to keep your client waiting when when it does all sorts of things. And that's the third party interaction. So now it's over to the other service to deal with the third party, because these services done their part. Now it's its turn to communicate with the third party depending on its availability, because that service will have the failure retries and circuit breakers and whatnot. And these two services, the order processor and the mediator, they need to work together. And this is where the orchestration and choreography come together. So with the step functions, we have the task token. So they come in handy here. Next session, Sarah is going to dive deep into that particular area to give you a more view of how they operate. And the other event goes to the NPS provider. So there is another service that receives an event, deals with it. So as you can see, they kind of separated out, and they all independently perform as they should be. Okay. Now, where do we find events? Where do they come from? So there are a number of ways. So event storming, if you're familiar with DDD, and events bridge storming. Ben Ellerby, who gave a talk earlier, he talks about event bridge storming. So there are a number of ways to identify the events that are part of your domain microservices. Now, if you bring that diagram back, two things I would like to identify here. So there are domain events, and in this sort of setup, you also have the operational events. It's okay. People may say that, oh, no, that's not an event. An event should have 4 wheels and a steering, etc., etc. But I can say that, yeah, fine, but my events can have 2 wheels and a handlebar, okay? That also goes a bit faster. So you need to be flexible and practical when you identify the events. And I'll show you later some of the things that you need to be mindful of. So keep that in mind. So many of these events, they kind of float internally. They never go outside of the boundary. The domain events are the ones they transact or go out or come in. So one of the patterns that are becoming popular with the event bridge now in place is like to have a gatekeeper bus. So the gatekeeper bus is the one will interact with any external services or application wants to interact with this one. So that's the one will send the domain events out and accept the events coming in. Whereas the internal event bus is the one that kind of used to choreograph the other services within the boundary. I mean, again, your requirements will be different. You can be flexible on that. So what's an event? So event is just a JSON payload when it comes to event bridge. So this is roughly what you see in an event bridge event. And the detailed part is where your data goes in. So if you're talking about order or a payment, that's where it goes. But what we have done is we have taken this initial schema or the definition, and we have kind of put some meaning to ourselves, because even though the detail takes any valid JSON, but if everyone dumps any old rubbish there, is very difficult to get any of the filtering patterns or routing rules in place. So this is where we come up with some kind of a structure, metadata and data. So I started to talk about this back in 2019, and nowadays this is kind of becoming a bit of a way to structure the event. So if you talk to Luke from Post-Terminal, he is there, and also David Boyne, he is around. So they all taken this structure and kind of making good use of it in a different way. Say, for example, they use the metadata to send the sort of standard stuff. Okay, so where is this event coming from? What do I need to take care of, like trace ID or even TTL if you are an upstream event going down instruction, okay? So I need this, the data to be there for 3 months or 100 days or whatever. So all these things possible with your metadata, whereas the data is more the instant data. The particular order or a particular payment or anything specifically, whereas the other one can kind of give a bit more of a the standard. So this is kind of becoming a pattern, and again variations of this are already in place and in good use. Okay, so the experience. So I've been through all these things, and what do we what do we gain from doing all sorts of these things? One thing is, if experience is something we need to go through. Without that, we can always listen to somebody talking about their experience and go home happily, but it's not going to make any sense for you unless you go through it, you go through the pain and the success and everything and learn things from there. Now, for us, the team growth. So back in 2018, we were a very small team and a few engineers and the thing I talked about. And 2019, when we moved to serverless, we had typically two teams. The typical backend was a serverless team and the front-end team, and a bunch of engineers, doing the serverless services as well as all the, the front-end, the React and JavaScript, those kind of things. But now, 2022, it grew a lot. So we kind of split into smaller team structure. So it's more like a Spotify model. So as you can see, the product teams, smaller product teams are like kind of 7 to 10 people, a product owner, a QA engineer, and other engineers. They kind of work together. So not all teams doing serverless, but because serverless heavy teams as well as the full stack teams are also front-end focused teams. So this is possible because the architectural decisions and the recommendations we put out to other teams, and they can innovate and do things quickly. Most of these teams operate with their own repository, operate with their own account, so they have the autonomous, they look after their products, they are in charge of running things and deploying things. There's another team which will kind of push out the tools and the recommendations, the best practices, but it's up to each the team to our squad to implement that and make it better. And they also look into the observability, monitoring, and Luke from our team, he's leading the payments platform team. So he can talk to him and he can give you the observability side of things. In terms of business growth, and since we migrated to serverless, the scaling is not a problem at all because it scales just like that. I mean, the stats for up to 2020, because I think we stopped collecting stats because it was so exciting those days, but now it became kind of everyday occurrence. So even today, I think new product launches, I'm sure there's a huge spike. So spikes in the sense we see these sort of vertical or the fountain spikes every other month or every other big occasion. So in terms of serverless scale, nothing much to do, except in certain cases, they would just put a few provision concurrency settings and take those down as soon as the event is over, but otherwise, serverless just scales up. Okay, so these all things were possible because of the choices we made in terms of technology, that's serverless, and in terms of the then we developed the the solutions, breaking things down, not kind of tied to the textbook style way of doing things. Of course, there are the practices and things are in place. We have a bunch of service audits and best practices and things in place, but otherwise have the freedom to kind of innovate and come up with the new ways of doing, all within the the boundaries of the best practices and things. To close, William Gibson once said that the future is already here. It's not very evenly distributed. I'm sure we can take inspiration from that and we can say that future is already here, but it's not evenly distributed. So let's make use of the event-driven architecture to be that medium or to be that enabler to get us the speed. Thank you so much.